Let's start the second part of the video homework guide for section 4.5. And for this video, I will start off with question number 5. And for question number 5, I have a taxi driver that charges $21.50 to travel 15 kilometers. And then we're charging another $37.10 to travel 28 kilometers. So for part A, I need to find the cost per kilometer. Okay, so as soon as I see the word per, that's the same thing as finding the slope. Rise over run, right? And what I'll do here is I will just use the numbers that are given to me in my problem to set up a table of values. So I have $21.50, so $21.50 for the cost, and that's for 15 kilometers. So 15 goes there, and I'm also charged $37.10 to travel 28 kilometers. Okay, so there, here are my coordinates, so 15, 2150, and I also have 28, 3710. All right, so in order to find the slope, it's rise over run, which is a difference in the y values divided by the difference in the x values. So my first y value that I'll use is $37.10, so $37.10 minus this other y value, which is $21.50, all divided by 28 minus 15, so 28 minus 15. Okay, and if I do that, if I actually go to my calculator and calculate this, this gives me a value of $1.20, so 120. So $1.20, and this is $1.20 per kilometer. Okay, so here is my slope. It's $1.20 per kilometer for part A. Okay, for part B, I need to find the equation that shows the total cost T. So here's my total cost right here, and it depends on the number of kilometers, K plus a fixed amount. Okay, so for part B, I need to find the total equation here. Okay, so over here, I kind of constructed a little graph here, and maybe we can kind of sketch the graph so that we can actually find the equation here. So I know at 15 kilometers, if I drive 15 kilometers, the cost is about, it was $21.50. It's around there. And then if I drive 28 kilometers, the cost is about $37.10. So somewhere around there. And I need to draw a little line here. So the question is, I need to find the equation of that line. And we also need to find the y-intercept there. Okay, so we've got to find the equation of that particular line there. So let's start off with what we do know. We know the equation for any linear line is y equals to mx plus b, right? And now we need to change the variables to match the storyline of the problem. So here's y. What does y represent in this problem? Well, if I take a look at my graph here, I have y is my total cost, right? So the variable that represents cost is t. And then ask yourself, what is the slope? Well, the slope we found in part A of the problem, which is $1.20. $1.20 per kilometer. So my slope is $1.20. $1.20. And then what is the x value? What does the x variable represent? Well, the x variable represents kilometers, which is k, and then plus b. Okay, and then one more thing we have to do is we need to find b. And remember, b is the y-intercept, so the b represents this value right there. So we do need to find that value. And what we can do here is, I'll go back to my original problem here, and notice that we have 15, 2150. So one of the points that was given to us in the problem was the point 15. So 15 kilometers would cost $21.50. So using that point, we can use that point to help us find the letter B. Okay, so this is your t value and this is your k value. So that goes there. So this would be $21.50 equals to $1.20. And k is now 15. Just get rid of this color there. And then plus b. All right, so we're just solving for this, and let's go ahead and calculate this. So if I went ahead and solved this, it'd be 2150 equals 2, and then if I multiply these two numbers together, $1.20 times 15 is going to be 18 plus b. And then if I move the 18 across, so now I have to take this 18 and move to the other side. So that's going to be 2150 minus 18. that's going to be $3.50. Okay, so my equation for this particular problem is T equals to $1.20 K plus 350. And that is my equation for that particular problem there. So a little bit of work for that problem, and a little bit of algebra, and definitely use your calculator to do some of these tricky calculations here. Okay, let's go to part C here. How far can a person travel for $53.90? Okay, well, I know that my total cost equation, we just figured this out from part B, is T equals to $1.20 K plus 350. All right, so this was her answer this was her answer from part B. And now we want to find out how far can we travel if our total cost is $53.90. So I take this $53.90 and I plug it in over here. So this is going to be $53.90, and that's going to go to $1.20K plus 350. And now our goal is I want to find how far, which is measured in kilometers. I want to find the value of K. Okay, so let's do that. So I can minus 350 from both sides. So 53.90 minus $3.50 is going to be that's going to be $50.40, and that's going to equal to $1.20K, and then I can divide both sides by $1.20. If I do that, that cancels off, and then K would equal to, so $50.40 divided by $1.20 is going to be $42, or not $42, 42 kilometers. So 42 kilometers is your answer for part C. And finally for part D, so let me just erase all this. Okay, so for part D, I want to find the domain and range, right? So what I've done here is I've just kind of went ahead and did a table of values here. So the question is, I do need to find my domain and range. So earlier on, we did find this particular value when we drive 0 kilometers. The Y value, or the Y-intercept, was $3.50. So I think we determined that in part B. And I know that the slope, we know the slope was $1.20, $1.20 per kilometer, right? So every kilometer we add another $1.20. So if I drive 1 kilometer, we would add $1.20. So for sure, we need to find the domain and range, but it might help to kind of construct this table first, because the domain and range is essentially what the table is. And this is going to be, what, $4.70. And then if I add another $1.20 to that, that's going to be $5.90. And $5.90 plus another $1.20 is going to be $7.10 there. Okay, so let's go ahead and figure out what my domain and range let's go ahead and find the domain now. Now the domain is simply just your kilometers here in green, right? So that's going to be 0, 1, 2, 3, ... And my range is simply going to be all these values here, which I'm trying to highlight in yellow. So the first value is 350, then 470, then 590, and then 710. And then ... Right, so there's your domain or range for that particular problem, and that's it for question number 5. Okay, let's move on to question number 7 here. So 7 should be another long question here. I think most of these questions are pretty long because there's part A, B, C, and D. For question number 7, supply and demand is always related to price. So, suppose demand for a video game is 4,500 units when the price is $30 per unit, and then it's going to be 3,000 units when the price is $40 per unit. Okay, so that makes sense. If the price goes up, I guess the number of units of the video game sold should decrease. Okay. Now the demand right now, let's go ahead and do a table of values here, because essentially we have to, for part A, we have to write some kind of linear equation relating price to units sold, right? So units sold, I'll use the U variable, and price will just use P, right? So P and U are the units that we'll use for this particular problem here. Okay, so I have 4,500 units, so my demand is going to be 4,500 units. So U is my unit there, and that is going at a price of $30. And then we have 3,000 units when the price is $40. So if the price goes up, quantity demand should go down. Okay, great. Let's go ahead and find the slope, and then let's go ahead and find the equation as that is the instructions for part A, 7A. Okay. All right, let's go ahead and find the slope now. So slope is rise over run, which is the difference in the y values. So here are my y values. So the difference of that is just 40 minus 30. And then what's the difference in my x values? Okay, that's going to be 3,000 minus 45,000. All right, so there's my slope formula there. And if I do this in my calculator, I get negative 0.006 repeating. And if you turn that to a fraction, that's negative 1 over 150. Okay, so there are some calculators that can convert those decimals into fractions quite nicely. Okay, great. And then the second part is I need to write the equation here, which is y equals to mx plus b. Okay, so ask yourself, what does y represent? Well, y represents the price, and x represents the quantity demanded, which is measured in the letter u, and then plus b. And then ask yourself, what is the slope here? Well, the slope is negative 1 over 150. Okay, so that's good so far. Now what we need to do is I need to find the y-intercept. So what's the y-intercept? Okay, well, what I can do to find the y-intercept is that I know one of the points that are given to me on this particular problem is when we sell 3,000 units, the price is $40, right? So that's one point that was given to me. For sure, I could have used the other point, but I'm just going to use this point for now. Okay, so this price now, this P, will now become, it correlates to $40. This is negative 101 over 150. And the number of units is being sold at $40 is 3,000 units. And then finally I have that plus B here. All right, so now you can go ahead and find out what the value of B is. This is going to be 40. And then if I go to my calculator and type in 3,000 divided by 150, that's going to give me negative 20 plus B. If I bring the negative 20 over, sorry, not sure why I put negative B there. If I bring the negative 20 over, it's going to be 40 plus 20, which is going to be 60. And therefore, my final answer is price equals to negative 1 over 150U plus 60. And that is my answer for part A.